Hello, hello, my fellow mathletes. Root Beer here, looking at question number 15 on the 2018 Fermat paper. If you'd like a copy of this contest, just a quick reminder, you can get a copy by clicking the link down in the description and trying the questions out for yourself. With that said, let's get into question number 15 together. So, 15 here. Francesca put the integers 1, 2, 3... is this going to be a magic square? Maybe not because of these numbers over here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 in the 9 squares in the grid. She put one integer in each square and used no integer twice. Okay, sensible. She calculated the product of the 3 integers in each row and wrote the products to the right. Okay, so the product of these 3 is 56. Product of these 3, 135. All right. She calculated the product of the integers in each column and wrote the products below the corresponding columns. Finally, she erased the integers from the 9 squares. Which integer was in the square marked n? Okay. So let's just copy this down. Now we might be able to figure out n without having to figure out the others. And if that's the case, I will just figure out the others at the end, just in case you're interested, assuming I can. There might be no way to figure some of the little things out. I saw it was a 21 here. I do not remember the others. 108 and 60 and 48. Okay, so when I start to think about products, you might be tempted to do something like A, B, C, D, E, F, G, H, I, and so H and N are going to mean the same thing. But what I'd like to focus on is the numbers that we can use. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, some of these are quite special when it comes to multiplying and factors and factoring, and those would be your primes. So 2, 3. These are nice, interesting numbers, but when I see something like 56, that doesn't necessarily mean a 2 was in that row, just a factor of 2. It could have come from the 6 or the 8 or the not the 9. But if I see 48 as a multiple of 3, the 6 could have been there, maybe the 9, I don't know. Okay? Well, not 9, because 48 is not a multiple of 9. But the things that I'm really interested in here are 7 and 5. Because the only way you can get a 5, and 135 clearly has a factor of 5, same with 60, is to have 5 in that row or that column. So that tells me right away 5's got to go here. Same thing if we start looking for multiples of 7, 21 and 56. Both share a 7. And the only way they could get a 7 is if 7 is in their row and 7 is in their column, so a 7 goes up here. Okay. We can also start looking at bigger things like, 9. How can you get 9? Well, you could get 9 by itself, or you could have both the 3 and the 6. So, not always the most helpful things. But this gives us sort of a hint. Maybe we want to start looking at factors and prime factors. So this is 3 times 7 down here with 21. Now, how could I get 3 in there? I can't use the 6 because then I'd have a factor of 2. And I can't use the 9 because then I'd have another factor of 3. So I've got to just have 3. One of these two has to be 3. But then what's left over, how can I use 3 numbers but just be getting 3 times 7? Well, that's where the 1's going to come into play. So one of these numbers is 3. One of these numbers is 1. Okay. We could look at other factorings. 56 is 8 times 7. Well, we've got the 7. And so that could be 8 times 1, or it could be 4 times 2. Now, the 1's already spoken for. He's somewhere down here, right? So we're going to have 4 and 2, or 2 and 4 here. Okay, now we're particularly interested in n here. So let's actually look at the rows and columns that have the n. So we could have 108. 108 has factors of, it's 2 times 54, so there's actually a 4 there. So it's 4 times 27. Okay. So I've got 4 here, and that's great, or a 2 here. But how can I make a 27? I need 3 factors of 3. Well, I know 3 is already spoken for. So I'm going to have to use the 6 and the 9. but the 6 gives me a factor of 2. So I can't have the 4 here. I'm going to have a 2 here, and either this is 6 and this is 9, or this is 9 and this is 6, and this is really narrowing down what n can be. So now, what about 48 over here? Well, 48 is 3 times 16, which is 3 times 2 to the 4. There's only one factor of 3, and that rules out 9. N's going to have to be 6. Okay, I don't know where all the other numbers are, but I do know n is 6. Now you'll notice I didn't make use of the 5 here, but I didn't know that at the time. Okay, you just start exploring. You try and figure out, what can I say about this and this and this. It's like figuring out a magic square or a Sudoku puzzle. You just start looking for patterns and fitting numbers in where you can, ruling out possibilities. Okay, was this the only way to go about it? Certainly not. I don't think so. We used the 7 a lot. Could have used the 5. Could possibly have used the 5. 60, you've got a 3 somewhere in there, and two what do I want to say? 2 factors of 2. So there's certainly that going on there to get a 60. So you have to ask, well, how can I make a 60? And yeah. So n is 6. I'm going to try and figure out the rest of this, just because saying that. So if the 2's there, we've got to have a 4 there, which means there has to be a 3 here. But then how the heck did I get 21 over here? Did I copy these numbers down wrong? I did. It's a 160. Okay, now I'm less freaked out. But let's just make sure I didn't... Yeah, okay, so 160. So we know we've got the 2, we've got the 4. I'm just now filling in the rest of the puzzle, just for fun. So no 3 required there. Good. But we've got 2, 4, 7, 5 spoken for. I know... let's make another one. So this is just for fun, filling in the rest of it. 7, 2, 4. I know there's got to be a 5 there. The 9 has to be here. The 6 has to be here. Now, 135 is 27 times 5, so the 3's got to go here, the 1's got to go here, and that forces the 8 to go here. 8 times 4 is 32 times 5 is 160. The whole thing has been filled in quite nicely. So there we go. But our answer of n equals 6 is all we needed, and that is D. So we bubble in D, and we move right along to question number 14. So I will see you for that in the next video. Until then, have a wonderful day, and take care.